So domain range. Now it starts off fairly gentle, even though you're like, what? I have to flip it both ways, okay? So you're normally thinking of a graph up here, right? So first I have flipped it vertically, it goes on to underneath the x-axis, and secondly I've flipped it horizontally, so that's why it is getting closer to 0 rather than racing away from 0. Okay, so there's my general shape. I have my horizontal asymptote there, it's got to be labeled, and I have my point per scale way on over here. Okay, because it's to the power of, it's the base is 3, that's why I've got 3 over there. You've got your domain stated, and there's your range, of course, because it has to be negative and it never touches the axis, so that's why it's not inclusive of the boundary. Alright, this was an easy one. Maybe I should put this one first. Anyhow, you needed the intercepts on there. Please make sure that the person you're marking has the intercepts. And of course, all real values of x, all real values of y. Alright, now here's the square root function. Okay, now because it's 4 minus x, okay, that means Minsu. That means that even though normal square root looks like this, right? Okay, because there's a minus on the x, it's being flipped horizontally. That's why mine is facing the other way. Okay, because there's a 4, it's been moved over to the right. Okay, it's a bit tricky because it's a 4 minus x, which is really actually minus of x minus 4. That's a bit weird. Do you remember we talked about this? The minus actually applies to that whole thing, and minus 4 means to the right 4 units. Of course, you could have just put in x equals 4 and see, oh, okay, it works. And so that's where it ends. You should have a filled circle right there. And so there's your domain. X is going to be less than or equal to 4, and your accompanying range. Okay, and then we've got, you can see I messed up mine on my own. So there's my hyperbola. It's been shifted horizontally and vertically. It's been shifted horizontally 2 units to the left, which you can see from that +2, and it's been shifted 4 units upwards, which you can see from the -4. Even though that's a bit of a mess having those two shifts and therefore those two asymptotes, the nice thing about it is because it gives you 2 intercepts, so you don't need points for scale because your intercepts function as your points for scale. Okay, so you've got your domain there. Excuse me. Thank you. And as I've said, this is the way that I like to state it. You can see I've got x minus 1, so I've been shifted 1 unit to the right. Sorry, that's a bit better. 1 unit to the right. So there's my new asymptote rather than x equals 0, which is my normal asymptote. So it's moved over. That means I have a new intercept because my intercept is usually 1. It's been moved over to the right, so now it's 2. Now the trickiest part is to work out a point for scale, because you should have a point for scale on this one. Okay, this point here, it's a bit hard to read, but it's e plus 1. The reason why I've chosen e plus 1 is because what I want is a nice easy number, right? So if I do log base e, even if you don't know what e actually is, if I put in e plus 1 in there, oops, sorry, don't end the bracket, and minus 1, because that's what the function says, okay, that's going to give me log base e of e, very good, which of course is just, oh sorry, that should be 1, okay? So that gives you, like, it's about as close as you can get to a nice convenient value. So you could have put in a decimal and it would have been okay, to be honest, but that's a precise way of doing it. Okay? Alright, let's move on to this absolute, oh sorry, I forgot the domain range. So x is greater than 1 because it never touches the asymptote, and of course y can go anywhere it pleases. Absolute value, it was a nice simple absolute value. It's been shifted to the right 4 units because you can see it's x minus 4. And you can see, therefore, you've got all real values of x as usual. Y can be equal to 0 because, of course, if x is equal to 4, you are actually at that point, so there's no discontinuity or anything like that. Okay, so now we have the semicircle. We talked about, very briefly, the forms of the equations of semicircles. You can see it's y equals, so see that minus is really on the y, which is why I've got the bottom half of the semicircle. From 16 minus x squared, if you want to think about it in a crude way, let's do it here. If I square both sides, I get this. You see that? That would be squaring both sides. Of course, once you do square both sides, that means now you've got both halves of the semicircle. So you don't, both halves of the circle. So you don't really want that, but it gives you an idea of the shape, because once you move the x squared over the other side, you see it's a familiar circle with center origin and radius 4, right? So once you remember that, that's how you get your intercepts, and you just want the bottom half. You should have filled circles at the ends because you can be equal to x equals 4 and negative 4, because taking the square root of 0 is fine. And lastly, the cube root of x. This is a tricky one. We haven't really looked at it, and even mine is not particularly impressive, okay? But you can see it behaves very, very much like the square root of x in terms of like it's growing, but it slows down and slows down and slows down. The difference, of course, is while you can't take the square root of a negative number, you can take its cube root. Like the cube root of negative 8 is negative 2. Because if you do negative 2 times negative 2 times negative 2, sure enough, you get negative 8. So the cube roots of negative numbers exist. By the way, just as a bonus, right, it's a cube root, right? Cubed, so it's like a 3. What kind of symmetry does this function have? It has odd symmetry because it's just like the cubic function. In fact, it's what we call the inverse. We'll get into that in more detail later. So you've got this shape. Not that you should, I wouldn't mark it down because I haven't gone through it formally, but just for the sake of it, see this y-axis, right? The cube root function should actually be tangent to the y-axis. See how I'm actually flat there? Like it's not going to pass through like the sine and the x curves. You know how they do this. So you can see it's not vertical there, but the cube root function, it is vertical there. Don't worry, we'll get into all the details of that later, but just so that you can note that for the future. Okay, so I wouldn't mark that down, but it is correct.